Hello everyone from Sweden. So this is gonna be an interesting actually start because this time we will run this series in English because we used to do this in actually Turkish for my follower, but this time we're gonna run it in English actually. But before we start, I would like to check the sound and the video. If everything is okay, we can just start. And then meanwhile, let me briefly introduce myself. I'm Caner. Actually, so I have a company called Alp Electronics. Also, I am a hardware design engineer. Actually, in parallel to this, I work at ABB in Sweden. No, it's gonna be in English, guys. So sorry. Yeah, actually, so in these actually series, yeah, great. In this series, actually, we're gonna make an ESP32 smart screen, which is nowadays actually very popular. You might see actually in a couple of different companies. I just want to show you actually some examples. So we can just go. Right now, there is actually one product from Espressif. You might know it. It is 2.4-inch screen, and then with some just connection interfaces, like docking station, sensor interface, bracket, breadboard interface, and so on. And then I think there is one from the company. I forgot its name, but anyway, so there are lots of actually devices nowadays, especially for IoT and smart home and like smart devices and so on. So at the moment, actually, we are designing. Sound is a little lower. Okay, we can increase the sound a bit. So what about now? If it is okay. So yeah. So for some of you already may know me actually. So we have a company, and then so we have these screens we already sell in our website. So you can go and check alpelectronics.com. We have services and shop, so where we sell like development boards. So at the moment there's only one development board, which is Raspberry Pi RP24, and together coupled with actually ESP32-S3. And we have some wireless modules and like some DC-DC modules and displays. And more is on the way. It's coming, but it takes time actually, of course. Great, yes. So yes, at the moment, so we wanted to actually leverage this screen in a better way. So we wanted to make a smart screen actually to add the value to it. So this is a screen. So let's check the product sheet briefly. So you can access to this product sheet from our website. This is a 4-inch actually 484 by 480 resolution screen with IPS, and it has an RGB driver, and the screen, the color is really good. It's not actually 16.7 million, which you can usually see from the phones or the computers, like in the high quality screens, but this is actually quite reasonable for such a device. This is like 262 thousand color, and it's 18 bits RGB, and it has an FPC connector. And the good thing of this one is actually it has a touch screen. It's a multi-touch screen, capacitive touch screen. So it's 4-inch, and this one is quite popular as well nowadays. So yes, there is not much to check here actually. It's just only the like probably the pin diagram and the sizes and so on. But what we have made is like we have actually prepared 3D of this product, so you can just insert into your PCB, and then you just don't need to actually worry about these dimensions and so on. But of course, we are just providing like to make it as good as possible. So briefly, just let me explain this. So the screen or the touch glass is actually driven by another IC, as it's common. So and that's controlled with I2C interface, which you see is like touch panel int. That's the like interrupt signal, like the STA, the serial data, and the clock and the reset. And then there is the power and the ground. The good thing is that this actually FPC is connected in the main actually LCD FPC. So it's like together. You just need use one connector. You don't need to have the second connector for the CTP. Yeah, M stack is really good as well. Yeah, it might be similar what we do, but there are some limitations at the moment. So I'm gonna mention to that before I start actually, or maybe while I design the PCB, I'm gonna actually mention a bit. So yes, and the before you use the screen, you just need to adjust the some settings like register and so on, like how it works, like like the like refreshing rate, like and so on for this like scanning direction and so on, because this is an RGB. And then in the RGB mode, you need to constantly supply the data actually, like driving signal. It's not like an SPI actually. You just like send signal and then fill in the memory because they usually have a memory for the SPIC like driven displays, and then you just like keep the data until you refresh it. But here actually this is different. You need to constantly supply data. So that's why you need to have an MCU which has the capable of like driving RGB signal. And then since it's constantly driven, so that should probably has a peripheral, a separate standalone peripheral, and then to be able to drive it like very well efficiently. Well, you could do this in the like main loop of the MCU, but and then you would use your resource for that purpose, and then probably you wouldn't be able to do anything else besides. And then we have SPI signals, which is like STA clock chip select, and then this is like pixel clock display enable. This is the vertical synchronization, horizontal synchronization signal, and so on. And then there is the backlight LEDs, and there are like 4 in series and 2 parallel. We see actually here that circuit diagram. We will need to have an actual driver for this one as well. Probably a boost driver, because we will have only like 3.3 volt input to the module, or maybe 5 volt, depends, depending on the application case of, but probably 3.3. And then you will need to boost that one. So that can be controlled from the MCU. Actually, you can adjust the backlight level like with a PWM or like I2C. Of course, depends on the driving mode or the IC, that boost IC, if it's controllable with I2C and so on. Anyway, so yes, let's go into the details. So I'm using Altium. I have been using Altium like for more than 10 years. Actually, I like Altium a lot, and then I really suggest you use Altium as well. There is a free trial link, 15 days, in the description below the video. If you haven't used Altium, I suggest you check it. Yes, so I have prepared, of course, this actually before this stream. There is some like some actually something here, but of course all of them are not implemented. So at the moment, we have decided to use like some sensors and like some interface, some peripherals. So this is the block diagram. So main thing here is the actually LCD. This is a bit misleading actually. We put this one, but this is our another product just to try drive this actual LCD standalone with another like breakout board or something. But this is a standalone breakout board, like to drive this screen easily and with different voltage levels, like 5 volt input tolerance. So you could just buy this breakout board and then connect the 4-inch LCD, and then you can just drive like with using using any of these like three connectors. There's FPC, 1.27 millimeter pitch, and then 2.54 millimeter pitch connector you can use. There are 3 options. But anyway, and then if we go further, there will be the power supply. There will be, of course, an LDO, but actually the plan is this might have been changed because we need to have an USB here, USB input actually here. So just this had a bit different purpose actually. So it has being shaped a bit like on the way, so to say. So as we go further and like we do some changes, of course, since this will be a, like a product that we want to sell, so we are thinking and changing some ideas. So there is the boot button. Maybe it's not a button, but maybe it's a jumper. But of course, so we haven't decided yet. I'm not sure about these indicator LEDs, but there might be an addressable RGB LED, and then user buttons, yes, of course. And then yeah, of course there is USB Type C in here. Yes, we will have USB Type C, micro SD cards, and then user connectors. So we were thinking to add actually a LoRa module and an NFC reader. Probably this won't happen, but we want to leave some space, like module space, that you can install your own module. But we will see. And then we have a like temperature, humidity, pressure sensor. And this has changed as well, and this has changed, and this has changed. So light sensor, we want to measure the air quality since people can actually install this one to their houses. So it can be a smart home device, basically. And then I was thinking to actually make it more like a generic device. I thought that I could add a speaker, and then to add a speaker you need to have a codec and have the amplifier, but it seems that we won't be able to do this as well. There is some limitations, and then so no microphone, but there will be a motion tracking, and then we will use this LSM from STM32, and there will be no infrared receiver and transceiver as well. So, but this is gonna be optional. What we can do is we can just uh, put a rectangle here, and then so say that this is just optional. In these videos, actually, I use Altium, but the main idea is to actually teach and show like the hardware design, system design, how we approach actually when we design a product and so on. So how we take the decisions, and like also component placements, component like selections, like bill of material selections, decisions, and so on. So you would be able to understand it as well. So it's not just like showing Altium and then how we put like things together and then like design the PCB. No, we just do like show how we connect things, how they work. So it's from the hardware design perspective to PCB design and product design perspective as well. Anyway, so yeah, let's go into the ESP32-S3. So this is a module that we use, and it is this one. So we use a ESP32-S3 mini one. It has like flash up to 8 megabytes and optional RAM 2 megabytes PS RAM. So this everything is like in one package. The advantage is you don't need to do any like certification for the module. Of course, for the product, you still need to do the certification and CE and marking and so on if you want. But this is a different thing. So the advantage is everything is like already like adjusted in the module, and then it's quite cheap. Actually, it's not worth like to design using the chip itself, because the antenna is like PCB antenna and so on. Probably you will need to use the ceramic antenna, otherwise you will need to spend some time adjusting the antenna and so on. Yeah, like it has a dual core 240 megahertz 32-bit microprocessor from Xtensa Cadence, I guess. And then it has like some good peripherals like SPI, LCD interface, camera interface. We will not use a camera. UART, I2C, I2S, remote control, pulse counter, LED PWM, USB, OTG, USB serial, JTAG, and so on. Yeah, basically, so the block diagram of the mini one. Usually my videos are like, actually my stream videos are like not short, unfortunately. Like it's not like 10 minutes video or something, so don't expect anything short, because hardware design itself usually takes quite a lot of time. And then I do this actually during the live video. I do everything is like spontaneously. And then there is the schematic. It shows like an example how you can use it. There are of course important points. This is sort of maybe internal schematic. Yeah, this is how you can use the module. Like it gives you an example. I always suggest you check it before you do anything. Dimensions and so on. But anyway, so yeah, let's go to the schematic now. So I actually design my own symbol library usually, but we have been using actually Celestial library, but I have changed the name to IP Electronics database. So you can go and check. Actually, you can download and use it as like a standalone library as well for your own. Of course, I have modified a lot of things and I have added our own components to this library as well. So this is used across the company, in our company. So for 3.3 volt, we are using a ferrite, but this might change actually because it has some self resonances in higher like frequencies, unfortunately. So we put a decoupling capacitor for 3.3 volts, and then like after the ferrite and before the ferrite, as I said, this will be probably a 0 ohm resistor. So don't just pay attention that if it's making you confused. And there is one voltage supervisor in case if a battery is used, but so we might actually skip this one and then just put pull up or pull down here as well, depending on the logic how it's working. So actually we can start from the screen. I have already, of course, as I said, like designed some of the parts. So the screen is the 4-inch screen that we have. We have developed this symbol and so on. So as I said, this is an 18-bit actually interface, RGB screen. But as you might notice, we are just using like 16 bits. Why? This is a limitation from the ESP32 because it only supports 16 bits actually RGB signal. 16 bits actually makes like 65K colors, number of colors. So the color quality will be reduced, or like if you want to have like those exact colors what you see on your display will not be displayed actually on that screen because of the color limitation. And another limitation is actually on the ESP32 is like number of IOs are not enough, unfortunately. So good thing about this ESP32 is that there is a multiplexer on the pins, so you can route any signals to anywhere usually. Actually, there are of course some dedicated ones, but usually you can use any signal to any pin. Yeah, at the moment, so we are using, as I said, like 16 bits RGB signal, and that is like divided. Yeah, divided like R, G, B. Like you have 5 signals for R, 6 signals for G, and then 5 signals for B. Yeah, blue, red, green, blue. And then we have some like control signals like pixel clock. So this pixel clock is a clock that this is like as a pulse like for each bit actually, each color bit. And then there is display enable, there is like vertical synchronization, horizontal synchronization. So the display actually goes in the vertical direction, let's say, and then like one line is like 480 actually pixel. So once that 480 pixels actually finished like framing, and then that vertical signal actually like goes high, or is it the horizontal? Yeah, I think it's the horizontal, goes high and then low. And then when we actually finish this vertical actually refreshing, and then that vertical signal goes high. So it's like one is horizontal at the end, the other one is like vertical at the end. Yes, and then as I said, this can be routed to anywhere. So pixel clock, and then the other signals you might notice that is not here actually, the enable and so on, because I'm gonna use an IO extender. And then because to make more like iOS for us, there is only vertical synchronization and the horizontal synchronization signal here, and then like reset reset touch screen reset, display reset, and then the display enable and the touch screen interrupt will be managed by this IO expander actually. So yeah, and then yeah, we have these I2C signals to actually control the sensors. As we said, we have sensors. I'm thinking an alternative actually here. So if we don't have these, for example, we can add this this actually 0 ohm resistors by making it oh, so in Altium, let's just select columns and then value and the device package. I'm looking for the device package. Yes. And then enable columns grouping, device package, and then the value. So is grouped really well together. So I usually use actually 0603 for this company, because we have our own actually pick and place machine, and that can usually handle 0603 very well. And then I want to put a 0 ohm resistor for some selections that we can have. This is a special purpose. I will explain you later. So either we can use actually this one or this one. So it will be a variation. So the same signal can be used as an SPI, or it can be used as an I2C. And then in this case, of course, if you don't place these ones, you wouldn't place these ones either, because this is a pull-up resistor, but it needs to be actually adjusted on the actual circuit depending on the pin input impedances actually. For this one, there is a really good application from TI, Texas Instruments. I suggest you to check it. I think it's like some companion, like for some circuit designers or analog guys, business pocket reference or something. It mentions there. It explains you very well. So my aim is to actually make a variation. Like either I want to use this SPI or this I2C. Why? Because I2C actually goes to all these devices, to the sensors, and then probably to the QWIC connector as well, the SparkFun QWIC connector, because we want to have external connections, right? Why did I use 47 ohm resistors? It's obvious because there's a termination. These are termination resistors. When you drive a signal in a high speed, you usually have these like peaks and these like decays and like overshoot, undershoot usually. So to eliminate these effects, you need to have these serial resistors, basically. It can actually vary between like 20 ohms to 60 ohms, 100 ohms. But again, I suggest actually you do the actual measurement on the hardware after the first prototype. You see that overshoot and undershoot. If there's a problem, if the signal is like inductive, or like if it's capacitive, you would need something else as well. But according to actually my experiences, like usually 22, 33, 47 is good. Yes, and then how we actually adjust variant is I have created a variant, so you go there. Okay, but what you do is you just create add variant here, and then you create a variant, and then I have a variant here. No variation and then variation. So you can of course change the naming or add more variations. Variations help you a lot in Altium in such a design, because for example, you may not want to use this actually resistors in production, but you may want to use these ones to have this connection. So this is actually what usually big companies do when they have a like common product. They don't design like every for every single different product if they are very similar. So they make it variations. Anyway, so I want to have this actually sensor connection by default. So I want to remove this one while I go here. So this is the variation editor mode, and then you go there and then you just say that not fitted. You see that part is not fitted anymore. So when you export the PDF as a schematic, you're gonna see that this is not fitted. And then when you send this for actually manufacturing, you will see that this actually component is empty. Yep, I'm gonna show you that one as well. So by default, we have this I2C connection. And then there is one trick here, what we want to do. This is a microcontroller actually. This is a really good microcontroller, I can say. But the thing is, it's very cheap. It is like $0.6, 60 cents. Let me just check it. I want to show it to you. Ah, not this one. Maybe this one. Yeah, I think it's here. Yeah, this is an M23 core 32-bit MCU actually. And then it is like this is an LGA package footprint. I think it is F8V6. So F8V6. So it's this one. This one we have. So 64 kilobyte and 8 kilobyte RAM and so on, so on. Yeah, it's like pretty decent actually, and it's like very small. And there is an ADC as well, so you can do everything basically. Yeah, the only disadvantage that you need to actually program this separately to have this connection actually between ESP32 and this one. But the thing is here actually ESP32 is like quite full at the moment. You see, like there is no connection almost anymore. So left, just like 2 4 5 actually connection, and then this one, yeah, 6 connection left. So we cannot do much about that. And then rather we could just add actually either like I2C IO expander, which I don't like because that's quite limited, and that's just an IO expander, and then it is probably more expensive. It's probably like $1 something. Well, if you don't go Chinese. But this is a really good and cheap alternative actually to have everything here, and then it has like how many pins? Like 15, 16 pins actually. And then these are actually IOs as well, like 17 IOs. It's quite nice, 17, 19. And yes, so this was to I2C connection, but as I said, I want to have maybe um, I'm not sure actually if I should combine this like this I2C here, and then I can have this outputs controlled with the I2C. So it's gonna be a like single device, but the purpose would be like, and then the question here is like, what are we going to do with these outputs actually if we connect this with I2C, and then well it will control these signals and this SD card detection definitely, but what about the rest? Don't care about this. So this is the programming pins that we're gonna add later, and this has its internal actually oscillator. We're gonna use those internal oscillator, so it's not, so we don't need any external component as well. The reset signal requires a pull-up signal, pull-up resistor, sorry, and usually 10K. And then there are two supply pins. One is VDD, the other one is VDD-A analog, and this is usually for ADC. I supply to the both pins actually 3.3 volt. Because the logic level will be 3.3 volt on this board. And then let's check. Yeah, and then yeah, it's quite a nice actually device. It can go up to 72 megahertz maximum, which is quite nice actually. So you can use it as a sensor controller, like standalone sensor controller. You can just program it, and then probably it supports Arduino too. I remember because this Giga device is actually cross-compatible with ST32 microcontrollers. But I think they are now nowadays becoming their own actually business. So like they have newer devices like M7 and so on. And then let's check other sensors that we have found. Um, uh, we have an accelerometer and a gyroscope. Well, this is called a six-axis device. Always on, it says actually it's like very low power, so it's usually suitable for these battery powered devices. And power consumption is very low. As you see, the analog supply voltage is like it's going from 1.7 to 1 to 3.6 volt. This is really good because we want to use 3.3 volt as the board voltage logic level. And then it supports its PI and I2C. This is important because we want to use I2C to reduce the number of IOs that we use. But do you know that I2C has one disadvantage? Because of the pull-up resistors, I2C actually consumes a bit more power compared to SPI. So if you want to make a really, really low power device, you should use SPI instead. Well, nowadays there's one more trick they do, a trick actually they do. Um, they only turn on I2C while or whenever they want to do a reading actually from I2C or from the sensor. So when you don't use I2C or the sensor, when you don't read the data, you just turn it off, that peripheral probably, usually, and then you actually reduce your power consumption. And this of course prolongs your actually battery lifetime. And then there's UI and so on. It says standard, and then free fall, wake up, orientation, click and double click. So you can just program it and then it can just give you those signals automatically. It says. And then we have one more sensor. It's from Bosch, BME L688. Digital low power gas pressure, temperature, humidity sensor with AI. So everything is actually in one device, like gas, pressure, temperature, humidity. This is really nice for us, and it has actually some this air quality stuff as well in it. So like volatile organic compounds, like volatile sulfur compounds, and other gases such as carbon monoxide and hydrogen in the part per billion ppb range. Additionally, 12 features of the BME 680D 688 has a gas scanner function. Yeah, it can so detect for bacteria growth. Gas scanner can customize with respect to sensitivity, selectivity, data rate, and the power consumption as well. The BME AI Studio tool enables customers to train BME gas scanner on their specific application, like in-home appliances, IoT products, or smart home. Yeah. So this looks like a quite suitable product. And then the important thing is that actually we have this I2C and then we have this SPI, and I2C can go up to 3.4 megahertz. So it's quite fast. But probably we will run it at around like 1 kilohertz or like 400 kilohertz. Sorry, like 1 megahertz or like 400 kilohertz. And then it can be powered with 3.3 volts. Still same for VDD IO interface. So IO interface, which is the actually logic supply voltage, obviously, and this is the core actually supply voltage. And then it's quite like low power, like microamps, and then it can go into sleep mode, or you can actually add one more stuff. You can add like a load switch, and then you can just turn it on and off and then you would further reduce the power consumption if it's like really important. The connection is this will be a slave device, but I'm thinking to have actually SPI to have a faster communication between them. But I'm not sure yet. So the one idea is actually connect SPI here and then connect all I2C devices through this one. So SPI would need to actually communicate, or ESP would need to communicate to this one through SPI, and then this should actually control all the sensors through I2C and then send all the data back to ESP32. Yeah. Or vice versa, just connect I2C to this one and then to the sensor. So make it everything slave, but don't connect any slave device to this one. So this would actually reduce the programming overhead, but the speed would be limited as well. And then we might need to remove this one in that case. So we might have an option. Yes, guys, how is it going so far actually? Like if you can give me some feedback, if that's okay so far. Um, and then let me go to, not this one, sorry. Let me go to the PCB. By the way, this is our development board. You can check it on our website actually if you want to purchase it. It has ESP32 and Raspberry Pi 2040. It's a quite nice one, and it's quite affordable. I'm using a cloud actually from our server, so that's why it's downloading all the time. So yes, as I said, we supply all the information actually for the display. Like you can get 3D step files and so on. So we have these, so you can import and then see it. We have all these connectors, everything as well. So I have been planning some for this product, so how it can be. So I'm thinking actually, so we can have this screen and then the PCB on top of it. So we can have a glue, maybe not a glue, but double-sided tape. Sorry, the strong ones. And then we can have this case around it. So the plastic case, and then it can be like 15 millimeter like height. The profile can be like 15 millimeter high or like 20 millimeter, and then so we can have this this FPC will be of course bended towards this connector, and then it will come underneath this PCB, and then will go out from here, and then will be connected to this FPC connector. And the thickness will be 1.6 millimeter, because I will explain later why. Cannot be smaller, maybe 1.2 millimeter, but cannot be slimmer or thinner than that. Sorry, I need to just get some water. When it's a live stream, actually, it's quite difficult. I don't like doing actually video editing and so on because it takes so much time. Rather, I would like to just do the streaming and design online. So I'm thinking we could have a dock station as well for this device. And then for those remaining pins, we can actually route using another connector here. So like this ESP device, we can have this like dock station system, but they use an, I think, PCI connector here. Yeah, I think it's a PCI connector. Yeah, expansion PCI Express connector, yes. So I'm thinking the same, but in this case, the user case is important actually. The use case, sorry. The use case is important. So like, should I maybe take this actually connector to the side, ESP type connector, and then it can be like free to connect anything, and then we don't block it actually when we connect it to the dock station, and then this one as well, this QWIC connector from Sparfacan. So this is I'm still thinking, but besides those resistors actually have been aligned like this. Like you see, I don't know if you're able to see it actually. These like these connections. So I have actually intentionally adjusted these connections like this so I can have an easy routing here. So you see, it's like just going there. You see here it's green and white's green because I haven't adjusted the rules yet in Altium. So what you should do is when you're doing, you should go to your like manufacturer, PCB manufacturer's website. In this case, actually, for me, it's JLC PCB. You should check capabilities, and then you should actually have this information entered to this Altium rules, basically, clearance and so on. But what I'm gonna do is, of course, I have my actually import rules. I have actually done this before, so I have this rated already. Altium rules, yes. So I have created this one actually before, like Altium 4 and 6 layers rule. You can actually export or import this information in Altium. So this is quite straightforward and useful. You see, it's gone now. You don't need to like try to adjust everything like again and again and again. The wall mount option actually can be added to the plastic, like on the back side, to the lid basically. But that's to the mechanics guy. Probably we will do it, of course. But not only wall mounted, so we need to think about these like use cases. And then there is one thing, we will have a light sensor. I haven't just added it, so it will be here probably because I want to have this it here like here vertically somewhere here, like or maybe here, and it should be a like true hole one because of easy installation. Well, we can get an SMD one. So let me explain why I want to use a true hole one. We can get an SMD one, and then SMD would actually stay here, right? So you need to extend its light. How to say? You need to like have this light actually coming to the sensor. But how do you do that? You either use a light pipe, or you need to have this opening and so on, or maybe I don't know. So and then since this device actually will be like maybe on the wall or something, and then this will be difficult. So the easiest actually to use a true hole sensor, which is like a LED, and then you just actually route or you leave it actually on the shell. You just make an opening like 3 mm something, and then of course there should be a SD card. So I'm thinking SD card might be here. Actually, we can take many things here. So we should just need to be careful about this actually. This is the PCB edge. So this is the PCB edge. So if you just click or please press Shift S, you would have this single layer mode in Altium. In the selected layer, you can change your mode. And this is my actually board shape layer. So this is the board shape. So this is important. So we will have this actually plastic case. So starting from this edge, and then it will be just like this. So I'm thinking a sphere type, or like how to say. So I'm gonna try to empty this actually, or make the shape like this. So a bit like a sphere type opening. So the user can actually access to the SD card easily, because this is not a push-pull one. It's just you insert it and you just remove it manually. There is no spring in it. This is a cheap one. Either it can be, as I'm saying, like the USB might be here, or maybe we put those connectors here. And then, so we get one more connector and then put it here, maybe. But this is gonna be optional. So at the we don't know at the moment actually. So let's continue. So sensors are almost ready, as you see. We just need to make the connection actually. So this I2C and STI needs to go to the main page. But there's just one more thing actually. I don't remember at the moment. I need to just check. And actually, this MCU was used already for a project, so I see it and I copy. So it was, the first one was clock I2C, and then the other one is the STA, so serial data, and I'm gonna do the same thing. So SCL and then I2C. So we connect this one. So yeah, all I2C is connected together. So you control it from the ESP32, and then which is this guy. Yeah, actually I don't like this type of connection here. What I do is I usually have this one. In Altium you can just, what you do, control C and then control shift V smart pace, control shift V smart pace, and then do um, net labels only. Net labels, yes. Yes, you see, you have converted them easily to a net label. And then usually I keep them like on the corner of page, but you will need to have this connections again like this. Yes, we connect them. Yes. So we have this actually connection now. But there is one thing, guys. So imagine, um, um, so we connect to this one, okay? So we control it and we use it as an I2C expander, like IO expander. Good. So in this case, what happens if a data changes here and then you want to sense it? So either you pull it, I mean, you constantly read this data, I2C all the time, like every 10 milliseconds something, which you're gonna make it like very busy and then it's quite actually meaningless. So what you should do is you should add just like one interrupt pin. Like whenever any change in this one, it should send an interrupt to this ESP32, and then it should say that, okay, I have a new data, please read me. So in this case, you would eliminate all these like unnecessary actually readings. This would save you a lot of actual processing power. And then power consumption would be reduced as well, because why? You don't need to pull it all the time. For this one, we should go for this. This is a wake up pin. It means that when it goes to sleep, you can wake this device from here. So you can use this one actually in both direction. I will tell you how later. But let's do like this. GD interrupt. Sorry. And then let's create a port itself. like this. So keep it here. And then go there. Oh, this is empty. Good. As I said, I'm gonna have a bus here later on. So I can have it like at the moment. Yes. This should go here as well. For example, with this MCU, the second one, I mean, you can drive another like uh, even display and so on. So we should have actually bus solution here, which would make sense. But let's just first make it like this. You see how easy in Altium to do this stuff actually. And then signal harness. You can do signal harness as well as you can have like this one. I forgot its name, but I think it was something, but I forgot what it was. Sheet entries. What was it? No, was it harness entries? So you would actually like simplify this one by making it. Was it harness? No. Let's just figure it out. Just a second. It was actually something like this. No, second MCU doesn't need any bootloader actually, unless you want actually something. Uh, where was it? I forgot it. It's been a long time. No, I'm getting older. But it should be one of these. Harness connector, no. Harness entry, no. Ah, bus, yes, it is bus. It should be bus and bus entry. Yes. Sorry, guys. So you will have a bus. And then the name. So there was one trick here. I'm trying to remember here as well. It was the bus connection, but how? So we could just dump them in the ports. Cross sheet entries, no harness entries, ports, not labels, ports, labels, no harness. I think no. Anyway, bus entries. Just let me Google it. Altium bus entry. So yeah. I found it. I remember now. Yes. So yes, it should be like this. Yes, you see, you can simplify it easily. But you would be able to do this actually automatically as well. But anyway, I remember this. It's a square bracket, so you do it this like this. You db um, db 0 dot dot and 15 like this, and then we could use this one in actually. So and then you should have the port itself. So this signal is actually carrying all these signals, and then you should have this IO type like bidirectional. You could have one more thing, and then what we can have is we can have this harness connection, signal harness, harness connector. You can say that RGB data, like this. Yes, if you press X or Y, it flips actually in X or Y direction, so it's quite useful. And then what I want is so I want a signal harness connector entry, and then like this, yeah, dB. So we will have dB PC P clock. We will have these two as well. We have vertical synchronization and horizontal synchronization. So I cut it, and then just when pasting it, I use the smart paste, like Control Shift V, and then I select net labels. So I don't create everything one by one usually. I always do this. So I'm gonna adjust the rest later, and then just let me take this one. Oops. Then taking this one. So actually I don't need this one anymore. I can just do this dB. Let's see if it supports. It should support, yes. And then this one, and then this one, and we don't need this one. And then the signal harness. So yes, and then it should be like this. Let's say this screen. Yes, we just need to use this signal then. So this signal needs to be used like this. So just let me get this one and go into screen. So yes, we just need to have it here. And then we should have the same thing basically. So this should still remain like this, and then we should have the bus entry, because we will need to create the bus in the same way. and then the bus. Yes. So let's see. I think we have some problems. It doesn't support probably like this. Mismatched bus wire object on the wire bus. It should actually. Let me check. Altium bus in harness. Yeah. You can check and learn a lot actually from Altium's website. Yeah. Okay. The harness entry needs to be the same as well. You see? So that needs to have the same name. 0, 1, 15. And then probably it's gonna be okay. Now it's like a bit. So the problem at the moment is it's complaining because it doesn't actually match to the data now. The other one. So yes, what we need to do is just copy this one and then paste there as well. Just delete and then paste this one. Mismatched bus wire object on the bus. Still, why? Yeah, it's the same. Okay. Okay, guys. The problem is this should be a bus as well. Yes, it's now gone. And then this one should be a bus, not just a wire. Yes. You see? Great. So we carry all these like signals through actually this harness connector. Nice. Yeah. And then do we get this VS? Yeah, we get VS and HS, so we don't need this port connectors anymore. And then we need to have this peak log, and then we should have this display enable. Display enable, yeah, will be controlled through this one, as we said. So let me make this one as well. And then like convert them to net labels. So the order of this one is actually at the moment not important because we will need to check it later, these ones, depending on this actually programming pins as well. But at least what we do is we put it here, and then we shouldn't forget that we put these ones as well here. So we will need to connect them. Oops. For this one, it's not the harness is not needed because it's not that many. Otherwise, you will just complicate the readiness of it. The readability should be high as well when you design a circuit. Anyway, I think we are now 18 people, and then it's been an hour. How is it going so far? Like, do you understand it? Is everything okay, guys? I think some people were expecting to have this in Turkish. Although I have clearly stated actually it's gonna be in English. Yeah, or probably they haven't seen it, the message. Yeah, here, let me explain what I have here as well. So I have these I2C connections for these sensors. Actually, I've just copied the application circuit. Yep. I think this one, yes. So it says like you can have this mod 1 and the host, which is in case ESP32. You can connect through I2C or SPI, and then the connection is like this. So I have connected like STI, clock, chip select will not be connected. That's gonna be connected to VDD to select actually I2C mode. And then there is the address pin. I don't know if there is any more actually connection diagram. But you would probably understand everything better when you read the pin descriptions. And we have two different interrupts in this one. Probably I will not connect this one there as well. So I will just have it here, for easy access, control. Because this one has already an interrupt pin, and then it can understand what's happening, and then it can just actually like transfer the data, and then ESP32 can do anything. Uh, Same here. Strange that we don't have any interrupts actually here. Then you just, or there is no interrupt case actually. So this is the BME. Uh, you should download Altium. They have a trial license actually. Anyway, this one is like connected through I2C as well. Again, there is one actually variant selection here, depending on the placement of these resistors. So just mind that just one of them will be installed, assembled on the actual circuit. So if you go like this to the variation editor mode, in this one, this is correctly selected maybe. In this one, we need to select one of them. So I can just select this one not to be installed. But the thing is, what does this do? Actually, this just sets the address bit 0 of the sensor, either to 0 or 1. So if you just tie it to power, so it's gonna be 1. If you just connect it to ground, it's gonna be 0. So this gives you option actually to have two different addresses. So either just 1 or 1. So depending on the circuit connection, of course. So if you have actually two different devices which they have the same address clashing, so you can adjust them actually like this. Well, I haven't checked what address they have, but I just put these options because we're gonna have a space anyhow. But it's a usually good practice actually. If you have these options, you should make it optional on the actual circuit. Then you can have like the freedom to actually play with the board. We need to add the light sensor. I think I have selected something on LCSC. I sometimes use them. They're quite affordable actually for these cheap projects or products, so to say. But for important ones, I usually use Mauser and DGK, of course. Oh my god, I think it's deleted. Or maybe it is in favorites. No, I had my favorites. No, unfortunately, I didn't add them. So nice. Anyway, but there should be something like a sensors and ambient light sensors, and then package should be actually plugging according to their English. It should be plugging 3 mm. Yeah, and then I'm sure that, yeah, but not this type. I want a flat head, something like this. Yeah, maybe like this. This would be nice. Yeah, this would be nice because if we use a black case, this would be like this wouldn't seem so much. And then the thing is, it should have a 3 mm opening. So what we need to have is like just a 3 mm pitch, or what's the pitch here? When we say pitch, you know that pitch is the distance between two pins, and it's 2.54. So we should come to sensors, light. Ah, there is nothing here. Thank you guys. You can watch it later actually. Just save it. But don't forget to actually press the like button and subscribe to the channel. Otherwise, we're gonna suffer, you know. If you like this content to grow, just like and subscribe and share it actually, if you have a possibility to do so. But soon we can finish. So I want to do this. Actually, we can finish now because I'm tired as well. So we can continue later next week uh, on Friday, probably. But still, it will be in English, guys. So anymore, I will have the videos in English because this is actually more comfortable for me. And then because the company is, you know, located in Sweden, and then it's the customers usually like speak English, and it's good for actually to have everything in global nowadays. But yeah, we're gonna use something like this. Let me just get its number. Or maybe did I already get it? No, add light sensor. Yeah. So this is good for manufacturability. Otherwise, you would need to have a like light pipe to carry the light inside. Sorry. Just let me put its name. This will not be an open source design, guys. You can just copy it, no problem, but you cannot sell this design actually. Just let me tell it to you. Yeah. So it should have the name. The thing is, I already work at ABB, so the company language is in actually the company language is English, so everyone speaks English there very well. And then yeah, my everyday language is usually in English, besides Turkish, of course, speaking to my wife. Yes, we will have this connection here too, because QWIC connector uses this SCL and STA. I checked it. It's from SparkFun. So this is the micro USB. Sorry, it's Type C connector. We need to control the CC pins to actually draw power from USB PD and like so on. So it says like when it is in sync mode, you can have like current for 500 milliamps, and like when it's in USB 3, you can have 900 milliamps. So we need to add this, and this is the SD card connection. This is the decoupling capacitor, and then this is in one single actually connection mode, single data line connection mode. This is STIO protocol. It's very similar to SPI actually, but it has its like own, I think, addressing system for these SD card connectors. Anyway, guys, like I think we can close, but next week we can finish this schematic, and then we can continue with the PCB after next week. So I have introduced actually basically the schematic and showed you, and then you know who I am anymore, and then you know what we are doing, and you know the aim. Anyway, do you have any other questions before I close the stream? If you have any questions, please ask. Otherwise, there's a football match actually for Fenerbahce. I'm gonna go and watch it. That starts actually like 45 minutes later. Yeah, actually, English is very important for our industry. So because whenever you want to do something, everything is in English, of course. The main reason actually for me to learn English is because of electronics. Did you connect the USB direct to ESP32? Yes, of course. Yeah, there is just there should be just serial actually these resistors like probably 22 ohms, and then yeah they should go here, but I haven't done that finished yet, so because this was just here, and then we will need to have a like actually I should take this to the power section because we will need to have a some power actually organization as well that I will explain that later because I want to put a battery as well, so that should be managed. Why? Because the power should either be supplied from the battery or from the USB type C. So how should that be managed, and we should organize that one is important. Yes, any other questions, guys? Please subscribe, share the video for your support and like it. Of course, we need to use an ESD protection as well. That's very important. Then where is it? So ESD diode is like one thing I'm doing actually very common is like I put all my notes to the schematic because I I don't have time to do it now, but I know I'm gonna do it and I need to do it. So not to forget it, I do it actually. I just write it notes like this everywhere. Like add light sensor, like PCI connector, QWIC connector, and so on. Like external plug is required and so on. So for example, you should do that as well because I don't use a pen and paper anymore. So we should have a power management circuit here. But I will need to think of that one. Actually, we can copy and paste this one. This is our Raspberry Pi development board, actually power section. Um, we have a reverse protection. We have this automatic actually power selection. So when USB is connected and battery is connected at the same time, the USB actually supplies power to the battery, and then USB also like powers the whole board. But the battery is not used in that case. When you remove actually USB connector, the battery starts supplying power without any interrupt to the circuit. There is no free Altium, unfortunately. Altium is the like professional version of the circuit maker, and then they just sell it. Unfortunately, I have a license. They give me actually they supply me. Altium has a sponsorship actually for our channel. But anyway, guys, so we can have this charger, LDO, and the load switch and so on, power distribution switch for that circuit. But I will need to think of it. Anyway, thank you so much for watching. As I said, see you next week, and good night or good evening.